see how to derive an expression for electric field due to infinitely charged spherical sphere using Gauss's theorem. Okay, so here we have three conditions where a point is outside the shell and on the surface of the shell, and the point which is inside the shell. First condition we'll see. First one is a point outside the shell. Uniformly charged spherical shell is this one, the circle which is with a center and radius r, and over the surface there is a charge, uniformly charged distributed over the surface. We'll consider a Gaussian surface sphere, which is a sphere, and on that which is outside of the sphere, and on that sphere we'll consider a point P whose electric field is outward and normal, and even the area vector is actually outside and normal. Next one is whatever we have considered, that will write. So first one is we have considered a point which is outside the shell. Okay, outside the shell at a distance, and distance of the P from the center is small r, of a distance, at a distance r from the center O. Okay, and next one is to calculate the field at point P, electric field at point P. The Gaussian surface we have considered, we'll just write the Gaussian surface we have considered is spherical shell. Okay, considered is sphere. Okay, which is sphere of radius r from the center, and also which is passing through the point P. Okay, point P. The electric flux at point P we have to know. Electric flux phi is equal to E ds. At point P we are saying, at point P only a small amount of electric flux we are considering. So d phi is equal to E dot ds. Okay, and theta, cos theta, right? The theta is angle between electric flux and the area vector. It is 0, right? So cos theta is equal to cos 0 is equal to 1. So d phi is equal to E ds cos 0. D phi is equal to E dot ds. Right. Next is, therefore the total electric flux is phi is equal to E summation ds. Summation is the surface, the total surface of the sphere. Okay, the total surface of the sphere is 4 pi r square. So in the place of summation ds we will substitute 4 pi r square. So phi is equal to E 4 pi r square. This is the first equation. We know from Gauss law phi is equal to Q by epsilon naught, right? So Q value we don't know, but phi value we know, E 4 pi r square, right? So we'll substitute the value. E 4 pi r square is equal to Q by epsilon naught. So E is equal to Q by 4 pi r square epsilon naught. E is equal to 1 by 4 pi r square Q by epsilon naught. In vector form we can write E is equal to Q by 4 pi epsilon naught r cap, n cap. N cap is the unit vector. N cap is the unit vector. Okay, so first condition we have derived the formula, that is when a point is outside the shell, and second one is on the surface of the shell. The same one, on the surface of the shell is, if I consider here a point P. Okay, if I consider point P here, the distance of P from the center is actually r. The only one we have to change is the r. Here we have considered the small r, but instead of small r we have to consider capital R, and also we can just write the formula of Q also here. So we know that it is a surface charge density, right? Surface charge density sigma is equal to Q by S. So for second condition, on the surface of the shell, r, small r will be equal to capital R. Therefore, E is equal to Q by 4 pi R square epsilon naught. Hence, also we know, but we know that sigma is equal to Q by S. S is the surface, right? So, therefore, Q is equal to sigma S. This is from surface charge density value or the formula. Surface charge formula is this one, okay? So, Q is equal to sigma S. So, on substituting this in the equation 1, we'll get E is equal to sigma S by 4 pi R square, 4 pi R square epsilon naught. And S. S is the surface of the sphere. Surface of the sphere formula is 4 pi R square, right? We know that S is equal to 4 pi R square. On substituting it, sigma is equal to 4 pi R square by 4 pi R square epsilon naught. 4 pi R square, 4 pi R square gets cancelled. So, E is equal to sigma by epsilon naught. This is the formula for second case. And the third case is electric field is inside the shell. Electric field is inside the shell, right? So, now we have to consider sphere which is of radius r from the center and the charges are spread over the sphere, and we'll consider a Gaussian surface which is inside the sphere, that is also a sphere, okay, of radius r and which is passing through the center P. We'll write whatever we have considered. First is consider a point P inside the shell at a distance r from the center O, and let the Gaussian surface be sphere of radius r and passing through the point P, okay. So, the electric flux at point P, is d phi is equal to E dot ds, okay. So, d phi is equal to E dot ds, so d phi is equal to E dot ds, and at point P is this one, and so therefore the total electric flux that is summation d phi is equal to phi, which is equal to E dot ds, and here we can see cos theta is 0 degree, right? 0, theta is 0, so cos 0 is actually 1, so therefore we'll get E dot ds, and summation ds, surface of the sphere is 4 pi r square. On substituting this, we'll get phi is equal to E 4 pi r square. This is the first equation. And from Gauss's law, phi is equal to Q by epsilon naught. See, here we can observe there's no charge inside a sphere. Okay, so therefore, inside a spherical shell, the charge is 0. So, therefore, Gaussian sphere encloses no charge. Therefore, Q is equal to 0. So, phi is equal to Q by epsilon naught, which is equal to 0. This is second equation. On substituting phi in the value, or we can equate both the equation. Phi is equal to 0 and phi is equal to 4 pi epsilon naught. E 4 pi r square is equal to 0. So, E is equal to 0. Therefore, inside the conductor or inside the sphere, the electric field is 0. Thank you.